Hello. After lunch, I can already imagine lot of food, garlic smell, and all those things already happened. So I hope you enjoy this session. I tried to create a very nice website. I would say I'm not a good coder or best coder, but I tried my best to make it very interactive and very interesting session for you. So bear with me. So look at the clock here. It's small, but you can see it's already ticking. So what I'm going to do here, I'm going to rewind the clock and I'm going to make you travel back in time, which is, of course, a difficult thing, but we will do it. So if you see the clock, it's already ticking, and every second, one or maybe other developers are writing vulnerable code. Every minute, we have some or the other vulnerabilities closer to our production environment. And every hour, our cost to fix those vulnerabilities are multiplied. So definitely, if I have a power or I have a privilege, I am not going to create any new scanner or any new better firewall. I will create this time machine as a tool, which will help you to go back, fix everything, and then you will be, you'll be cost effective, and your applications, your software will be secure enough. And this is not just, I think some of you might already be thinking that this is another security talk where I am talking doing more with less. No, look at the stats here. 70%, if you follow this time machine, which I will try to cover in next 45 minutes, 70% fewer vulnerabilities and 60% faster recovery will be there, and definitely the cost will be reduced to fix those vulnerabilities. But before that, I would like to introduce myself. My name is Akansha. I got very nice introduction already. So I'm from India. I'm here living in Netherlands for almost 4+ years now. I have 10+ years of experience in cybersecurity, and that's why you can imagine how patient I am to create this kind of website for you all, to make you understand what exactly the fancy word shift left or DevSecOps means. I did a couple of certifications, so you can already see I did a lot of things because I'm from mechanical background, and this was my journey from balancing the load of machine to protecting DOS, like DDoS using load balancer. So it was a roller coaster journey for me. I write Medium blogs sometimes, which are mainly focused on API security, because that is my favorite topic. So feel free to read and provide any feedback if you have. Follow me on LinkedIn. You can reach out to me, and we can discuss about API security as well. Okay, coming back to time machine. So, the reactive security nightmare. What you see on the screen, bugs all over around. And as I already mentioned, I'm not a very good coder, so it took me a while to make it really fancy where you see all the bugs. So it's like a horror movie, and we are already in a Halloween atmosphere. So it's like a horror movie where you have a monster inside your house, and you are just waiting for him to get out by his own. So what it is. So here you see the traditional SDLC lifecycle, where you see different phases: plan, code, build, deploy, etc. And the bugs floating there are nothing. But if you see on the screen, yeah, it's visible. So if you see in the plan phase, no threat modeling was done. No requirements were mentioned, what exactly you were trying to create, what your application is going to do. In the code phase, my favorite vulnerability, which I identified a lot, that is SQL injection and cross-site scripting. So you can imagine this nightmare and the consequences of traditional security, which is like still afterthought for many organizations. So why exactly we are doing it? Why we are not planning well? Why we are not using our code scanners? So I hope in this session you will get a lot of information, and you will made it happen in your organization after getting the understanding. Okay, so you see two blocks here. One is your reactive failure and one is your proactive prevention. So in the reactive failure, I took few examples which were with very good example. I would say move it happened in 2023. That was just a normal SQL injection. Why it happened exactly? Nobody knows at that time. And then another example for 2024 Okta, where there was dependencies, there were configuration-related vulnerabilities. So that happened. So this was the reactive failures, which were mostly people were aware that they are going to happen, but no steps were taken upfront. And if you see proactive prevention, there it is mentioned like, what if? What if we cover our SAST, our input validation, and then we know that we just need to have like small parameterized queries which can, I know if some of you are not technical, then it would be difficult for you, but I will try to help you understand how you can mitigate the very fancy vulnerability SQL injection using a parameterized query or prepared statement where you specify your strings when you take inputs. Then definitely, if you have a policy as a code, then you will definitely able to make it happen that your deployment gets broken. Your CI/CD pipeline will be broken, and then you will know what exactly happened. You don't have multi-factor authentication implemented, or some kind of authorization measures were missing. So these kind of proactive measures, if you take, definitely things will happen. Okay, let's talk about something business, because maybe some of you already with the business mindset, which is always like cost. What is the cost? What is the money which is going to happen when we get any kind of vulnerability? So if you see the graph here, it's like exponentially increasing. Whatever you get as a issue, as a vulnerability, and you fix in your first stage, rather than fixing in the production, it will cost you 100 times. So each step gives you an idea when you have to fix, where you have to fix, and how much cost you have to reveal for this. So you see, and it's not about fixing. It's not just you have, okay, I have some vulnerability which I'm trying to fix. It's your reputation, it's your data loss, and your downtime of your application. So if your application is not available for legitimate users, that is a downtime. That's what you are here to protect as a security professional. So in this, you see the graph is increasing, and you need to work for it to make it cost effective for your organization. Okay, so what you do, how you do, and what is this fancy word everybody is talking about? Let's shift left, what it is exactly. Because as a security professional, I hope some of you are already talking about shift left, DevSecOps, but what it is, how to do it. So it has three key pillars if you focus on, that is rewind, go back and make it as a secure culture, like embed security. Second step is like each phase has to have some security measures, not like a separate phase. And third, empower your developers. So it shouldn't be one person's job, it should be like everyone's job. So these are the key pillars. If you following the shift left culture, definitely it is going to happen. And the promise you see that 70% vulnerabilities will be fixed and you won't get in the production. All right. So this is the the phases which you see on the screen, like normal, traditional, life cycle, like plan, code, build, and test. What are shift left mean if you see this as a life cycle? So if I give you an example, this will happen when we shift left. So in the plan phase, we start with threat modeling. In the code phase, we have our static application security testing. In the build phase, we have a composition analysis where we do dependency testing. And definitely DAST in the test phase. So each phase has its own property of security. Security is not just like a silo or a separate blob where you can do it at the end. It's like each step has to follow some security measures. Then only you will say that, yeah, we shifted left, we have DevSecOps culture, and security is everywhere. So it's like a cultural shift where you integrate, where you embed security in your life cycle. It's like your developers are your security defender, not like just security professionals are doing it, but they also know what they are supposed to do while writing a code, while integration, while automation, everything. And then real success, I would say, GitHub already have a autonomous detection of any secret. So if in the code, if there is any hard code secret, it will be, get triggered instantly. So it is like a real world success which we have, about the shift left. So I tried to make it like a circular integration motion. I have a very nice picture later after this slide, so be patient. So each phase has its own security measures. Like if you go to code, you have build, you have test. So every phase has some common vulnerabilities and some security measures. So I will talk about them later I will explain them how you do it. But every phase has its own security measures and the vulnerabilities which are already known. So when we know that, hey, this gate is not good enough to go, why we are already following the same path? We can take another door, right? So this is how we have to prepare our developers. We have to prepare our engineers that they know. So suppose if I give you an example of this code phase where so yeah, I was talking about this fancy loop, which is my favorite slide, I would say. I spent almost a week for this. So because, because I wanted you to know that it's not a linear thing. It can't be a linear. See, security, we say that 100% security and all those things. But it can't be linear. It has to be in a loop. It has to feed from every phase the outcome is coming. It has to go to the other phase. So magic, I would say magic happens at the monitor phase where our SIM people or the people who are doing the 24/7 activity. So whatever we get from that monitor phase, it is getting feeded to another phase which is like planning. So in the next itinerary which we are going to follow for this SDLC infinity loop, we will get the help from feedback getting from each phase, and then we will make it more efficient, more valuable for the entire life cycle. So yeah, I hope you like the picture and the animation, because it is a lot of work, to be honest. And being just a security person, it was huge task to do, to just let you understand that it's not stopping anywhere. It's not just one time work done and you are finished. No, it's continuous. It's keep going. That's how the CI/CD pipeline also works. So it's an infinity loop, basically. Okay, so now let's talk about each phase. The first one is threat modeling. Definitely one of my favorite topic, where I spend almost 4 years of my career. How many of you, if I may ask, are like familiar with this threat modeling thing? You somehow did it, or you are part of it, maybe as a developer or something. Okay, so you already know some of the methodology which we use, like Stride, where we check what exactly we are building, why we are building, what kind of data it is going to have, what kind of people are going to use it. So all these questions you will ask when there is nothing, like no code, no plan, no existing application. That is the very first step. When you think about your application, you start drawing it on paper or maybe Confluence or any tool which can help you to integrate all the components you have and then create your application. At that time, you will get to know what could be the countermeasures for your threats, what could be the risk that can happen, how the privileges can be escalated if any other user is going to use your functionality. So these are the thoughts which you need to have when you start building these applications. So this is very most important, I would say, and very first step of your software development life cycle. Moving ahead, this is like a code scanning. So Fortify and all these tools help us to do that. But suppose this is the second phase, and many of us like already think that after coding security comes into picture. No, we already one step ahead. We started with planning. Now we are at the code phase. That is like after one phase we did. And if we do better in the planning phase, definitely it's less job to do in the other phases. So in the coding, we do scan all the code which is written by the developer. So it is like someone who is, I'm the developer, I'm writing the code, and someone who is standing on my head and looking at my code, what I'm writing, and instantly poking me like, hey, this line is wrong, this line is not correct, or these are the flaws you are making. So SAST is like that, like static analysis, which continuously scan whatever you write as a code and how you build your application. And definitely, again, API security is one of my favorite topics. So for SAST, APIs, like if you have APIs in your application and if you have implemented SAST, then it will help you to identify so many flaws, like how your endpoints are working, how your endpoints are interacted by how they are exposed. So it would be visible in one scanned report if you have automated testing for this one. So this was all like talking. So let's see how this code scanning works. Can any of you, I'm not sure if it is that visible, but I have seen, I have shown the vulnerable code and the secure code simultaneously, like together. So can any one of you please help me what the vulnerabilities there in the vulnerable code? Sorry? Yeah. That's good one. One is there. If I scroll a little bit more. So, it is, so suppose one of the developer wrote this code as a vulnerable code, and you have, you know already what could be the secure code here. And you know that what kind of things you need to protect your application. Like as I mentioned, for SQL injection, you need to have prepared statement and parameterized queries, and you can't just use these API keys or hardened secrets in the code. Suppose by mistake, if someone does that, what will happen? Like if you don't have any SAST scanner, it will just go in your production, and I don't know who is going to use those keys, those passwords, and what they will aim for. But suppose you have a SAST scanner and you just run it. So you will get to know that, okay, in the line 3, you got this vulnerability as called as injection, how you want to prepare it. These are the measures you can take. In the line this, you have this hard-coded secret. So these are the things which you need to understand, that in the code phase itself, your application still have to go through the pipeline. You are in the coding phase, you are just writing the code, and you got to know, okay, these are the things which I can already fix it. So this is how the SAST scanning works. And it's really cost effective, because you just have to invest in some of the scanners, and it will will give you impact later when you are in production or live environment. Like many of us claim that we own our application, but it's not always true. 70 to 80%, let's say that, are from the outside. It's dependencies. It's like outside sourced for our application. So we definitely need to have composition analysis to scan our dependencies to know what we are onboarding for our application, what are their attack surfaces, how we can protect that, and SCA can help us, because it will check all the dependencies, whatever your application is having. So it's definitely like a property of one phase in which we need to have these measures, which can also help you to protect your supply chain security, because sometimes it's very difficult that we have one application in which like 80% is dependency. Then how we are protecting, what we are protecting? We just sign the contract and we just say, okay, we just onboard these vendors, but are we protecting them? Are they protecting, or they are having the proper measures? So these are the things which are very important if I talk about supply chain security also, and this will help you in your SDLC cycle. So one of the phase is build. Going forward, this is the test phase, that is dynamic application security testing. So it's like our pen testers, they do amazing job. I'm not sure if we have any pen tester in the room. But yeah, they just create, like we have this Halloween atmosphere. So they create the entire attacks, like simulate the correct attack. And then they identify if that can happen or not in the production environment. So that's how our DAST play a very good role in protecting, in shifting left, or I should say, protect ourselves from having like worst case scenario in the production. So it's like a very comprehensive coverage of all kind of real-time happenings, and you can also have RASP in picture, which is like having a runtime self-protection. So it will also help you in the test environment. So definitely big kudos to all the pen testers and all the testers who spend a lot of time to just simulate one vulnerability, one known vulnerability which we have. Maybe they cover from OWASP top 10, maybe some other known CVEs. So they just create those kind of exploits and see how your application is working, what kind of application is giving the response. Is it properly maintained, or it is revealing some kind of information? All right. So next phase is like CI/CD, that is automated security gate. So if I give you an example of API security, definitely we need to have proper API gateways when you are exposing your API. So for web application, we have different CI/CD measures. So if you see here the example which I have given, like if you have this flow, GitHub, Jenkins, where your build will break, SNCC for code repository scanning, then Trivy, then deploy. This is like a secure CI/CD phase. So that's how we do. Like these are the steps which you need to cover while preparing, while onboarding of your any application, while having your application, and then it will give you a proper measure. So when we have this CI/CD phase, we already cover like SAST, we already covered DAST, SCA. All these phases are covered, and at the end we deploy. So this is like automated exercise which goes like with continuous integration and continuous defense together. So next comes our deploy phase. So let's not forget about like very powerful bouncers at the gate. They are like people when you go to any club and they are standing outside. They just make sure only people who are nicely dressed in like for the clubs and all those people, they are only entered, and rest discard. So web application firewall are those kind of bouncers which who just check, okay, this is the known thing, this shouldn't be the case. Or maybe some of you who just go for, work from holiday place and they just try to log in at 3 a.m. and then see, okay, what is happening. So they just block. So web application firewall is those kind of thing which help us having a zero trust. So, continuous monitoring, definitely security information, event management. So, I was giving you an example when suppose you are on a holiday and you just, try to do some work at midnight 3 from a known country, then your SIM people will know that, hey, someone is not allowed and they are doing work from there, and someone malicious is happening, and they just read the logs, they get the information, and then they let their manager know maybe, or they just try to put the measures there. So it's like a 24/7 job. They have to monitor everything. For that, definitely we have automated tools, maybe log analytics, Sentinel, which see what kind of logs we are getting. Is there any IP which are not in our scope, and they are the requests are getting from there. So this is 24/7 monitoring, and it's like real-time monitoring. So anything happens in SDLC lifecycle, it will be triggered for your application, and it will be notified by those tools which you use. Feedback and improvement. I mentioned that feedback improvement is like a cycle. So in every phase, from planning till monitor, you just do your checklist, and the feedback you receive, you just feed that feedback for the another phase. So if you see here, you do monitoring, you get some insight. Okay, these are the malicious thing happened. You learn from that. You improve your checks, your list, and then you try to do again the planning for another software or another application. So this is how like inside the secure development cycle, there are separate cycles which are going on. So every phase has to go through with one cycle. So that's how we do our feedback and improvements. Going forward, who are doing it? Like, who are the DevSecOps Avengers, or maybe the people who are making it happen? Everyone we talk, like I talk a lot about security, but who are the actual masterminds implementing it? That is the major thing which is happening. So just see the 6 major people I mentioned here. They are the DevSecOps Avengers who are actually doing the work in the place, not just talking about. So first is Threat Modeler, who are like strategic brains who are creating those difficult architects where you see, okay, this is the flow of our application, this is how our application is working. So they are the strategic brains. Then comes our Code Guardian, where we do like code analysis. They check what kind of code it is, how they are writing the code, if they are having proper standards or not, if they are implementing. So they are the Code Guardians. Then we have Dependency Detectives. So they are like supply chain security people, or who are doing the software composition analysis. Then we have a pen tester. So I think we might have some pen testers here. So pen testers, they are like, I would say, heart of the entire life cycle, because they actually create the environment, the essence of having an attack or getting exploited. So these are the testers. Then we have CI/CD, security automation specialist, which who make it happen by automating everything. So as I showed you, like how Jenkins get integrated, then other tools. So this is how the automation takes place. And the last is defender, so runtime protection, WAF. So if you see all these 6, they could be like different security professional. But if you see them as a one team, then definitely they are like a powerful DevSecOps Avenger, and like they are not working like dev or ops. They are embedding security in between, not as like siloed team, but they are all like one individual power as a team. Like they have separate powers, but they are working as one individual team. Then only DevSecOps will happen. So security everywhere, but how it is happening, you can imagine. Like every professional brings different valuable expertise on the table, and if they all are combined together, that's how DevSecOps comes into picture. Okay, so what is the traditional approach? I think security always comes afterthought, and it's always taken as like one separate blob, and then we have like full-blown inflation of attacks, vulnerabilities, and then we just, panic because we have to give a lot of cost for all those fixed. And this is like a traditional approach. So what we are trying to do here, we are moving from this traditional approach to like proactive. We are not just preparing ourselves for reacting to any disaster, but we are preparing ourselves. We need to prepare actually to proactively measure and proactively brilliantly secure, basically. So this is how we can develop confidence in our customers, like gain trust, automate prevention, and definitely reduce like 60% of vulnerabilities from scratch. Like not just wait till the production, till someone else is reporting, or maybe it's good to have bug bounty programs, but it's just waiting, sitting, and just if someone else is going to report any vulnerability for your application. So why not prepare now? Why not follow the DevSecOps culture and make it happen? Definitely it won't be 100%, but it's the case that 90% you will be able to solve upfront rather than waiting for someone. So the future of security engineering, definitely I'm not going to talk about AI. Maybe you already have so many sessions about that, but we are moving towards that. That is the future. So we can have, like you saw the code scanning tool. So you can have some AI-powered tool which can help you to automatically run. You can have some generative AI to create like a architectural flow or do the threat modeling automatically without any human interaction. I don't know if that can happen still, but you can try. So AI is like new way of working, I would say, and we can leverage so many tools already in the market, although I'm not a big fan of tools. But yeah, I have to say that if AI is the future, we have to onboard these kind of tools and make our lives easy. So that would be like less human interaction. Then I am here to wrap up, and then we can have maybe question answer. So these are the key takeaways when you go out of the room. I would like you to at least take these in your head, that these are the 6 key points. Shift left, that is like catching vulnerabilities upfront and knowing what your application is supposed to do, who are going to access, what they are accessing, what kind of data it is having. So shift left. Do the threat modeling, do all kind of planning, requirements completed. Continuously, security is, as I mentioned, it's still considered as a separate blob, like a separate phase. But if it is like a continuous thing, then it would be actually a secure culture in our organization. Then automate, leverage all the tools we have in the market, and it will help you to easy your task, not complete, but easier way. In an easier way, you can finish your task. Empower your developers. So many times in the organization, we experience that people, like developers, are not aware of even the basic thing which we have, like OWASP top 10, that these are the basic things which everyone should be aware of. They don't know. So I think empowering developers can really create a lot of impact for our secure culture, because when they are aware of all these checklists, all these standards which are already existing, it would be easier for them. Then measuring. Sometimes we just forget about this main key area where we have to measure our what was the mean time to detect, how many vulnerabilities we identified, what is the list of critical and high vulnerabilities from the code scanning, from the dash scanning, or whatsoever. So measuring gives you insight, and it will help you to plan for the other phases. And definitely collaboration. So these are the 6 key points which I would like you all to at least remember from this session, which will help you to bring this kind of culture in your organization. So thank you so much for your time. I think I did not take much time, and let's make it interactive. Maybe we can have some question answer now. So last point is like shift left, secure forward, and definitely you need to have some kind of collaboration within your team, outside your team, with your stakeholders, with your vendors. Let them like understand what you are trying to achieve from secure left or shift left culture. Actually, I just also wanted to highlight, because shift left is just one fancy word, or maybe just a marketing strategy. Actually, security is everywhere. So it could be shift up, down, left, right, whatever. So it's just a fancy word, or I could say that it's easier for people to understand that when we say, okay, we have to shift left, that means we have to start from the scratch. But we have to parallelly shift right, parallelly shift up and down everywhere. So every time you have to be conscious when you are doing anything as a job. And at the end, I would also like to mention that I used the color orange for my entire slides, because I really impressed by the national color of Netherlands, and because it gives me energy, warmth, and definitely let's not forget about the warning signs which you get with some orangish color. So yeah, that's it from my side, and let's have some questions maybe.
Thank you so much. Yay. I take back my words. You made a time machine. You made it. Are there any questions? I'll start at the back, because then I can go to the front. There was a question here somewhere. Oh, yeah.
Thank you for the presentation. My question is around supply chain management.
Yeah.
We do that, but there is always main concern of fatigue of how many vulnerabilities and what's the critical per product or per team, if we want to take a look. And developers are always in a battle with us, with DevOps teams, that I have a backlog to work on. I don't have time.
Yeah.
How do you address that in your current role or current team? And do you have any recommendations for supply chain management tool? Because I'm looking at RFP right now, so would like to have some impact.
Thank you for the question. I would say I'm not expert in supply chain management and security because that is not my part of expertise. But what I can recommend is whenever we have any dependencies or vendors, it's really nice to have create checklist upfront from your side. And then, while onboarding or while, when you are dependent on those vendors or maybe some other functionalities, if you have those insights from yourself, if you have a proper checklist, what exactly you are looking for from security point of view, it would be easier rather than just signing on and onboarding them. So if you make your expectation clear in general, if you make your expectation clear for security to others, then they will be able to make it happen. But yeah, it's really challenging these days from supply management because sometimes we have business pressure, sometimes we have prioritizing, like some things which we have to just, make it happen. And security is again, the afterthought, which I mentioned. So for supply chain, I think that would be better approach if you can do it. I'm not sure if that answers your question, but yeah, that's my take on this.
She's nodding like, yes. Next question. I saw somebody here. Oh, I hear there are manufacturers that you can recommend. So.
That is a better approach, that you have the composition analysis of your dependencies. So that is a good approach.
Yes, thank you. I'm here. I also recently was at a talk from ING, and they actually shifted from DevSecOps to RiskOps. So yeah, actually my question a little bit related to that, but the 6 characters you described, the 6 professionals, are they actually working within the development teams, or are they separate DevSecOps teams?
Very good question. So, as I mentioned, there is no DevSecOps team. There can't be. It's like development team, operation team, and security team, and some other. That's why we have the security champion also in place. We help coder to understand what are the security checklists to write a proper code within a secure manner. But they can't be a separate team. That's not the culture, and that's not the way of DevSecOps. It's like, that's how organizations are actually doing. They are just, making it siloed exercise and the painful exercise, I would say, because once the coding is done, once the automation is done, and then when you go to those people and say that, hey, you haven't followed these standards, they'll be like, okay, why you did not tell me before? So I think better way not to make it separate team, just parallelly do together. Like security professionals should be involved from the day one when the application has to build. I think that's why we have the threat modeling trainings, and where we make it happen together with the security professionals and the developers. So I'm not sure how things are in your organization, but better way to make it all together. That's how it is going to happen. And that's the whole concept of shift left or DevSecOps or RiskOps, which I got to know, so all these are fancy words, but let's not make security one person's responsibility. It's like everyone's job. Even if I'm walking here, I need to be responsible enough that I walk properly in these heels, otherwise I'll fall down. So it's everyone's responsibility. If they are writing a code, if they are automating things, if they are just business people, they also need to understand security. So it can't be a separate team. Although it is in many organizations, but that's how things will change if we bring a security culture.
Thank you.
Hi, thank you for all your effort on the presentation. I think it was lovely. So I have a question for you, which is, I'm not sure how far it is relevant and how far you're actually seeing this transition really into this AI generated code and everything. So I'm wondering, while the SDLC cycle itself so far is very clearly you have all of these phases, very clear line of demarcation between your plan, build, etc. But right now with the AI coming into the picture, a lot of these stages are not so clearly moving one after another. It's maybe just smushed together. So in such a case, in this scenario that we are moving into, like what would be some newer integration points that you might want to think about, or is that something that's already happening, like in your area of work? Like how do you really see this forthcoming?
Yeah, so I can recognize this pattern that we are using AIs and things are just, getting into each other and we are just overlapping things basically. So, if I talk about SDLC and secure SDLC, basically, if we are going to overlap, then we can't just skip the security measures which are supposed to be taken. If we are using AI, like suppose if I give you an example, if we are using our generative AIs to create a secure architectural flow as a threat model for our application, we can't just skip that humans are not involved there. We can't just skip the entire phase of planning. If I give you an example of maybe build phase or maybe deploy phase, we can't just skip that. We can definitely make it like overlap together with AI anomaly detection or other tools which are there in the market, or maybe we can just leverage those to make it quick or easy, make it easier for ourselves, but we can't just skip the entire phase. Overlap is still better, and I don't think so it is going to put a lot of impact from security point of view. Maybe I'm wrong, I'm not sure, but from my understanding, it is not going to create a lot of issues if you are really following secure SDLC for your applications or for your softwares.
And there was a question here.
Thanks for your presentation. So I like the idealized view of the secure SDLC, but we live in the real world and there's a lot of complicated software supply chain issues, and just the fatigue that comes from so much data out there. I'm wondering, so you say that the DevSecOps should not be a separate thing but integrated, but we're talking about the real world and the real trainings that people follow and they get into cybersecurity world. There's software engineering, there is, security related education, there's also other fields. How do you see these people coming from siloed, let's say, education programs coming into security and then integrating it all in one team? Because ideally, every person should have all the knowledge, but in real world, that's not possible. So how do you see that, in operationalizing security?
Thank you for the question. I would say, one person cannot do everything, that is for sure, but they can do all together, with someone's help, or at least it should be properly managed and properly, so suppose you mentioned DevSecOps, I'm not sure if it is a siloed team or if it is a separate team, in your experience, but what I can share from my experience is security professionals are there. Definitely they are different people. They can't just write the code but they can help you upfront when you start the coding. So they can give you the proper checklist, proper standards, what you have to follow, where you have to follow. And it's a big task to integrate everything together. So it's not one day, one activity, you are done and you are finished, you are secure. No. It's all together and it has to happen in I think you remember the infinity loop. So it has to happen in the overall cycle, and you can't just skip anything, and one person cannot do it all alone. So it's shared responsibility with shared information. Everybody has to aware of all those things which in the organizations it's difficult to follow, I can imagine, but that's the culture difference which we have to create, and that's the shift basically.
Okay. Well, thank you so much. Hands up for our presentation. Thank you.
Thank you.